Go ahead and get started, guys.
I'm trying to motivate my friend to do something. Yeah, do you like? Sorry, bad joke.
So sine of theta, its reciprocal is cosecant.
Wait, wouldn't it be just, yeah,
It's like 1
The tangent of theta
Oh.
is equal to 1 over the cotangent of theta.
Yeah, I'm confused.
And we have cosine of theta is equal to 1 over
Because on top it would be sine over 1. And instead it's 1 over 1. Yeah.
So here are the 3 basic trig functions and their reciprocals. I'm going to learn to talk over you guys. I'm just going to start one warning and then attention. That's how we're going to go with this. I've already gone over this. I know that you were not here, Lena, so we went over the classroom rules and the consequences because you've had some serious issues with talking over others and blurting out and so forth. So let's try to be respectful of everyone, not just me, but other students as well. All right, so these are the 3 basic trig functions and their reciprocals. So these are completely true. It's good to know. They're good to know just like it's good to know the Pythagorean identities. All right, so let's pick back up with implicit differentiation. Where did we leave off on this worksheet? Number 6. So let's see how we can do here. Let's start with 6. So 6 we have 1 is equal to 3x plus 2x squared y squared. Okay, so implicit differentiation is useful for when it is tough or not really a good idea to try to differentiate explicitly, meaning trying to get y as a literal equation in terms of x. So let's differentiate this implicitly. So the idea again here is to think about taking the derivative of the left side with respect to x and the same to the right, the derivative with respect to x. Same to the right. And so we'll go over this piece by piece so it's very clear, we make no mistakes here. So the derivative of any constant with respect to any variable is just going to be 0. Now over here, I'm going to go ahead and just break it up. So we have d dx of 3x plus d dx of 2x squared y squared. Okay, so 0 is equal to the derivative of 3x with respect to x would just be 3. And then we have plus the derivative of this. So now we should view this as a product. So let's view it like this. Think about it like here's one factor of the product, and here's another factor. So the derivative of this, product, so product rule says derivative of the first, which would be, now here's chain rule coming into play, to the front, so you'd have 4x, and then the derivative of the inside, derivative of x So dx dx. So we have that. Leave the next guy alone, plus leave the first guy alone, and then the derivative with respect to x of y squared would be 2 to the front, chain rule, power rule, 2 to the front, drop down, and then the derivative of y with respect to x, dy dx. So again, think of this as chain rule. You have to bring exponents to the front, drop them down, and the derivative of the inside. Yes?
So you just distributed the d over dx to both. Is that, like, I see where the 4x came from, but where, like, the dx over dx and dy over dx, where did all that come from? Yeah.
So let me answer one question at a time.
Okay.
You are allowed to distribute this to each term, which is separated by addition, yes.
Yeah.
So you're allowed to do that.
Mm-hmm.
Okay. So what this is saying, and this is back to that notation that we discussed like early on in the course. We said, okay, this is like saying take the derivative of this with respect to x. Okay. So the derivative of 3x with respect to x is just 3. We just know that it's just the coefficient of x. Then this part here, okay, so the derivative of this. Okay, so now we're starting to think about when we see things, we need to recognize when we have a product. Okay, so we see a product of 2x squared and y squared. Okay, so the derivative, so the product rule says derivative of the first factor, leave this guy alone, plus leave this guy alone, the derivative of this factor. So let's go ahead and do that. So the derivative of 2x squared with respect to x would be, okay, chain rule or power rule, 2 in the front, this drops down, and then the derivative of x with respect to x. Now, you're going to find out that this is just, of course, 1. It's a ratio, change with respect to itself, the same variable. That's just 1. So a lot of times you wouldn't see it written when we do it literally, so, but it's technically true, that dx dx.
Okay, I think, yeah, I think once we do a few more, I'll
this stays the same, plus now we leave this guy alone, and then now the derivative of y squared with respect to x would be chain rule or power rule, 2 to the front, drop it down, and then chain rule says, okay, now the derivative of the inside, which, okay, dy dx, wherever that is. We don't necessarily know what that is, so we just say, okay, dy dx.
Okay, I think so.
If it's with respect to x, how is it, why would you drop I don't remember how to do it. It was like, I don't remember what she said.
I don't really think she.
What's the question?
I don't know, I just understand it.
I thought it was just d over dx, or it's dy over dx because it's y to y.
What's that? Sorry?
I thought it was just d over dx, but is it dy over dx because it's y?
Yeah, so let's be clear about this. So this means d over dx says take. Yeah, you want like a scientific? Thank you. That's the one that they should be using on the EOC.
Okay.
Yes. Crappy, now I'm out.
All right, students sent me a
Oh, okay. Me too. So this d over dx, this is saying take the derivative of this with respect to change in x. We want to ask a question about this? Or is that you?
Yeah, that's not what you said.
So this means take the derivative of this with respect to x.
Yeah.
Okay. So you've been doing it the whole time. You just didn't think about it. Let me show you what I mean.
No, but
So-
my question.
What's the question? Yes.
Okay, I understand that. That's why I thought it was that. But then when you put dy over dx,
Mm-hmm.
why isn't it just d over dx? Because there's a y in what you're taking the derivative of.
Just like the y, the inside components of the y squared. So there's y squared,
So
so you
what
get
if-
inside, which is just y.
What if you had something that was like 2xy? And you had to take the
We would
derivative.
still separate.
Oh, that would be
and
the
x
product
and y, yeah.
Oh, okay.
Because this is like 2x squared y squared. It's
Yeah, it
basically
is.
2xy.
Okay. I got it.
You got it?
Yeah.
Okay. All right. So we are here. So then if we continue with this, we're looking to write dy dx on one side and everything else on the other. So dx over dx, again, that's just a 1-to-1 ratio, so that's just 1. So we have 0 is equal to 3 plus 4x times y squared plus 4x squared y dy dx. And now it's the matter of just algebra and moving things around.
Two to the 4x squared.
Did I do something wrong? 2 times 2 is 4. X squared times y is x squared y. Okay, we're good. So, all right, so I'm going to have 4. I'm just going to move this over. So I'm going to just subtract 3 and subtract 4xy squared. So we had negative 3 minus 4xy squared. And then last thing to do would be to divide each side by 4x squared y. I'll write it up here.
Can the 4 be negative? No. Oh, you're really good.
So can you cancel out this x's and y's?
Okay. So I know you weren't here yesterday, but we're going to try to get into the habit of, instead of just blurting something out, wait till something's written, look at it for a second. If you still don't understand something, you have a question, go ahead and raise your hand. Yes, please.
So can you like cancel those out?
Cancel what out?
The x's and y's.
The thing is that these are separated by
So you would have
addition
to
or subtraction or addition, so I can't really, there's nothing I can factor out of here. Now, if they all have something in common, I'll factor it out, but there is really nothing that I can do there.
Okay.
So this would be dy dx. So this would be the slope of any tangent line of, this graph here for any point x, y, where you can plug in the x and y coordinates.
Gotcha. Are we gonna translate?
Eventually, yeah. I'm going to see how much we're going to assign for homework. I don't know if I want to assign the whole thing, especially at the very end.
Can we do number 8?
Yeah, we can do 8. Sounds good. So number 8. Number 8 says 5x cubed plus xy squared is equal to 5x cubed y cubed. So we take the derivative with respect to x. So the derivative with respect to x of 5x cubed would be 15x squared dx dx. Plus, here I have product rule. So here I think, okay, derivative of the first, well, derivative of x, respect to x is just 1. Leave this guy alone. Plus, leave this guy alone. Derivative of this guy would be 2y dy dx.
Oh, man.
Is equal to, now here again, it would make no sense to say, okay, I'll let 5 be a factor and then let this be a factor, because then you have product rule to deal with again. So it makes sense to say, okay, I'll let 5x cubed be one factor and let y cubed be the other factor when I do product rule. I'm thinking of it like this. So the derivative of this is product rule, so which means I take the derivative of the first, which would be 15x squared dx dx. Leave this guy alone, plus leave this guy alone, times the derivative of this guy, which would be 3y squared dy dx. So eventually, with enough practice, or probably right now, you'll get the feeling that when I take the derivative of, let's say, x with respect to x, it's not necessary to write dx over dx, but technically it's true. So eventually you're just like, okay, but when I do something with the y, when I take derivative also of the y, I know that, okay, there's going to be a dy dx involved. And then it's a matter of, I guess, cleaning it up here if we can. Looks like I have a dy dx over here and a dy dx over here. So let's see here, 15x squared times 1 plus y squared plus 2xy dy dx is equal to 15x squared y cubed plus 15x cubed y squared dy dx. Gotta be careful, today's caps, so what's it? 11:15. Alright, so dy dx. So move all my stuff over that does not include dy dx and move everything where it's connected with dy dx on the other side. Then you'll end up factoring out dy dx and then dividing by the other factor. So just takes work. So here we go. So bring this guy over. So I'll have 2xy dy dx. If I subtract that quantity from both sides, so minus 15x cubed y squared dy dx is equal to, if I subtract this guy and this guy from each side, I would have 15x squared y cubed minus 15x squared minus y squared. Let's step back and make sure I did that correctly, not the same thing. Just be careful when you do these, not to make a simple mistake.
Does it matter which order you
What do you mean?
go in? Like, if you subtract it from the other side, like, is that anything?
No, as long as you're trying to get all your dy dx terms, you roll on one side, doesn't matter. I'll shrink this down a little bit more. All right, so now I'm here. So now in order to get dy dx by itself, I'm going to factor it out. So I'm going to have dy dx times 2xy minus 15x cubed y squared is equal to the right hand side. And then divide both sides by this. So dy dx would be equal to the right hand side of 15x squared y cubed minus 15x squared minus y squared all over this factor here, 2xy minus 15x cubed y squared. So dy dx could give you, again, the slope of any tangent line of the original equation for any point xy. Yes?
If you're taking the derivative of something that's like something plus y, would that just be, so let's say it's 3x plus y,
Mhm.
would that just be 3 plus dy over dx?
Yeah, if I took the derivative with respect to x of what you just said, yes.
Okay.
Yeah, I think that now I want you guys to go ahead and try to work some of these out with your partner and see how it goes. See if you can figure some of these out. It just takes one of those things that just takes practice and getting used to.